All right, guys, let's go ahead and work on the 5.1 to 5.5 review, the first part of trig. Okay, here we go. A couple of things that you will need to know. When we convert from degrees to radians, we multiply by pi over 180. Now, the way that you're going to remember that is that we actually want these degrees to cancel each other out. So that's why with degrees, we're going to put the 180 degrees on the bottom. Okay? So that those will cancel out. Now, I will show you guys how to do them by hand. I will also show you how to do them on a calculator, and I'll show you both types of calculators so you can use whatever you want. All right, let's see here. When you're doing this by hand, well, this is like a little tricky, but basically you go, well, what goes into both of these? I think 5 goes into 55 11 times, and 5 goes into 180. I don't know how many times. It's something I'm not going to do in my head right now. I think it's 36, though. Yay. Okay, it's 36. And then 11 and 36 don't have anything in common, so I would put 11 pi over 36. Okay? Now, if you're just using a calculator to do this, and it was starting back from the beginning at 55 over, 55 times pi over 180, you go into your calculator, and you just go 55 over 180, and you hit math 1. And I get 11 over 36. You just have to remember you can't put the pi on there and then, it won't turn into a fraction. So you got to remember to put the pi on at the end when you're done. And if you're doing Desmos, it's essentially the same thing. You just go 55 over 180 and this little fraction guy on the side here, you hit that and it'll turn it into 11 over 36. Okay, so however you want to do these, that's how you will do them, and you can reduce them using a calculator. So negative 275 and 180, I'll do that over here. So if I go, okay, negative 275 over 180, it's negative 55 over 36. So I would put negative 55 over 36, and then I would just remember to put the pi. You could put the pi out front or on the top. Either one of those would be okay. And then to show you another, way on the other calculator, 570 over 180, you just go 570, over 180, math fraction. And I get 19 over 6, okay? So then I would just go 19 over 6 and remember to put the pi in. All right. Now, when we are going radians to degrees, we multiply by 180 over pi, okay? Now, the way that you'll remember that is this time we want to get the pi to cancel out. And so that's why, we're putting the pi on the bottom so that my pi can cancel out top and bottom. Okay? And then again, I'll show you how to do this by hand, and I'll show you how to do this on the two different types of calculators. So what you do is you basically go 5 goes into 180 how many times? And I think we saw that was like 36. And then all that's left is a 2 and a 36. So 2 times 36 is 72 degrees. Okay? Let's see, it was 2 pi over 5, 180 over 5. Okay, so on here you can go 2 over 5, 180. All right, and get 72. Okay, and then on Desmos it's the same thing. You just multiply them out. So once you divide the pi's, okay. Okay, so like 7 pi over 12. So we're going to go 7 over 12. I usually just put it in parentheses times 180. and I get 105. Okay, so this one would be 105 degrees. And then here, negative 19 over 9 and 180. I mean, we can do it on here too. So we can go negative 19 over 9 times 180, and I get negative 380. Okay. All right. Now, do you guys remember when we did coterminal angles? Okay, coterminal angles mean that it goes all the way around the unit circle. All right. So when we are doing coterminal angles, it means we will add or subtract 360 degrees, add or subtract 2 pi, depending on if it's in degrees or radians, okay? So 210, to get 3 coterminal angles, we're going to add 360 to that, and then we'll do 210, and we'll subtract 360 from that. Okay, and just use a calculator to do it. So 210 plus 360 is 570. And then 210 minus 360 is negative 150. Okay? Okay, now, with the radians is a little trickier, right? Okay, so let me write this twice. All right, so remember how we would add 2 pi and we would subtract 2 pi. Now, when we were doing this by hand, I will show you how to do it on your calculator, but when we were doing this by hand, okay, we had to figure out, well, 2 is what over 7? Remember, we always were doing 2 is what over 7? Well, 2 is 14 over 7. So on each of these, instead of just doing 2 pi, I would do 14 over 7 because that's what 2 doubled is, okay? And then negative 2 plus 14 is 12 pi over 7. And negative 2 minus 14 is negative 16. Okay? Now, you can actually do these on a calculator as well if you don't feel like getting a common denominator yourself, okay? Negative 2 pi over 7, I would go like this. I would go negative 2 over 7 plus 2 and turn it into a fraction. That's where I get 12 pi over 7. And negative 2 over 7 minus 2 and turn it into a fraction. So it's 12 over 7 and negative 16 over 7, which I have. The thing is, you can't put the pi in the calculator except for we talked about that one type of calculator, all right, or it won't give you the right answers, okay? So again, let's do this one by hand because I actually think by hand is easier, and then I'll show you on Desmos. Okay. So I'm adding 2 pi, I'm subtracting 2 pi, but I have to say, well, how do I get a denominator of 11? All right. So we say what divided by 11 makes 2, and it's 22. Okay, and so 10, 20, 30. So this one would be 38 pi over 11 and negative 6 pi over 11. And these are my coterminal angles, all right? On Desmos, let's see, 16 pi over 11. So we forget the pi, and we just go plus 2 as a fraction. That's where the 38 over 11 came from. And then minus 2, that's where the negative 6 over 11 came from. So just any calculations you do, don't put the pi in there. It messes the calculator up. Okay, there's our first section. Here we go for our next section. The formulas that I am going to give you guys for this, okay, because we're talking about how I think these are the easier ones to memorize, is we're going to go like this. So, arc length, length wrong. Arc length is theta over 360 2 pi r, because that's the circumference of a circle, or theta over 2 pi r. Okay, this top one is in degrees, this bottom one is in radians. All right, that's going to be for arc length. So arc, okay, so these are ones are arc length. So let's do it. Okay, the first question, this is a radian value. So I'm going to go like this. 7 pi over 5 over 2 pi times 2 pi r. Now, if you want to cross off the 2 pi right here, like you absolutely can do that. And you can just cross that off and then figure out what's left. It does say to the nearest tenth. Now, even if you wrote down the 2 pi, you would be fine. Okay? So if I did this, right, a fraction within a fraction, 7 pi over 5 over 2 pi times 2 pi 11, and I get 48.38. Okay, remember, I don't care if you round or truncate, 48.38. So you could put 48.3 or 48.4. Okay, and we should probably say feet since they did feet. All right. Okay, so on this next one now, this is a degree measure, and degrees go like this. 230 over 360. That's what the degree formula is. And then we still go 2 pi r. Okay? 230 over 360, 2 pi r. So on here, I'm going to go fraction 230 over 360, 2 pi, I believe r was 6.4. Okay, and I get 29.6 or 29.7 if you're going to round. Don't write both answers, please. I'm just showing you guys which ones you could pick. Okay, pick one or the other. If the length of the arc is 10.3 and the radius is 3.7, find the central angle. This is important in degrees. Okay, so I'm going to use this degree formula right here. All right. And I don't know what the measure is. I just know it's 360. And then it goes 2 pi radius equals 10.3. Okay, now let me like split screen this so I can show you guys how to type that into a calculator. So we're going backwards, right? So the first thing I would want to do is multiply by 360. So I go 10.3 times 360. 10 got messed up here. Okay. That's what that equals. 3708. And then I have to divide by 2 pi 3.7. All right. So you can go like this. 3708 divided by 2 pi 3.7. Okay. And I get 159.49, so 159.5. So I'll come back over here and I will say that this is 159.5 degrees. All right, so I'm just like using these formulas. For area of a sector, let's look at the formula for that. Okay, for area of a sector, like look at how similar these formulas are. Area of a sector. Okay, it's still theta over 360, but instead of 2 pi r, which is the circumference, we do pi r squared. And it's still theta over 2 pi, but we just do pi r squared. Okay, that's for area of a sector because it's a part of the area of a circle. It's a fraction of. All right. So here we go. Find the area of the sector. All right. So my opening is 160. So it's going to be 160 over 360 pi times 7.7 squared. Oh, sorry. You got to square the 7.7 and then put that. Okay. So let me show this one on the calculator on here. So we'll go, just whenever I do fractions, I put parentheses around it. 160 over 360 and then pi times 7.7 squared. Okay? And then my answer is 82.7 or 82.8. You can round or not. Feet, because those are our units on this one. All right, and then, okay, so going back to here, that's degrees again, so we're just doing degrees. 265 over 360 pi radius squared. Okay. On Desmos, we would go 265 over 360 pi times 5.2 squared. All right. And we get 62.5. That one doesn't round. So we'll just say 62.5 feet. All right. But I'm going to give you those formulas, so you'll be fine. You just have to know how to put them into your calculators. Okay, guys. So I don't know if any of you guys caught this. You know, I go back and check and make sure that I didn't make any weird mistakes when I'm going through here. And I did make a weird mistake on number 2. Did anybody catch this one? I don't know what I typed, but it wasn't this. 230 over 360, 2 pi 6.4. Anyway, so yeah, I definitely typed that wrong. So 25.6 or 25.7 would work out on that one. Sorry, guys, but you know, I always seem to make these little mistakes. Plus, it's a little difficult typing into the calculator with a mouse. Okay, so anyway, hopefully that section looks okay to everybody. Let's move on to the next one. Okay, guys, when the triangles are just kind of like freestanding like these two are, we aren't taking into account negative values. All we're doing is sine, cosine, tangent, cosecant, secant, cotangent. Okay, so let's go through this. None of these have anything to do with the negative values. All right, what you need to remember is this. I'll write it down here. So this is SOHCAHTOA, right? Where we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then you guys need to remember that the flipped for each one, sine is called cosecant, cosine is called secant, tan is called cotangent. Okay? So, I mean, they'll be in order here, but later on in the review, they might not be in order. So, you got to pay attention to which angle specifically we are looking at. Like that one, okay? The one across from it, I will label opposite. The one across from the right angle, I will label hypotenuse. And the other one, I'll label adjacent. And then we just write them down. So, sine is opposite over hypotenuse. Let's reduce. We don't have to rationalize, but let's go ahead and reduce them. So reducing means, okay, 3 goes into 12 4 times and 15 5 times. Okay, cosine is adjacent over hypotenuse. 3 goes into 9 3 times and 15 5 times. And then tangent is opposite over adjacent. 3 goes into 12 4 times and 9 3 times. So we see that this is like a 3, 4, 5 triangle when you guys see those numbers come up together. And then now that they're already reduced, we can just flip them. Cosecant is 5 over 4, secant is 5 over 3, and cotangent is 3 over 4. Okay? All right, cool. Now for this one, okay, we have to do the Pythagorean theorem before we can start. And what I want you guys to remember is the hypotenuse is always the one it has to be equal to, which means if you're just going straight to the calculator, you're going to go 14 squared minus 11 squared. If you want to write it out, you can. Remember, this can be A or B. It doesn't matter. But if I go x squared plus 11 squared is 14 squared. Okay, so that's why we do 14 squared minus 11 squared. Okay, which is 75. And then we talked about the special calculators that will, if we try to square it, that it's a decimal. That's the nice calculators that'll just reduce it for you. And if you don't have that, you just go like this, really easily. Okay. So I end up getting 5 root 3. All right. Okay, now, again, starting from here and going across. The one that's across is opposite. Across from the right angle is hypotenuse. And then the one left over is adjacent. And so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then we'll just flip everything. Okay. And that's going to be 11 over 5 root 3. Okay, and we can just go ahead and leave them just like that. All right, now for the next one, we are going to have to draw the triangle ourselves. Draw it whichever way you want. Label whatever angle you want. You can do that angle up there or that one down there. Doesn't really matter. Okay. And with cosine is adjacent over hypotenuse. So from here, that side is opposite. That side is hypotenuse, which makes this side adjacent. So when I do adjacent over hypotenuse, okay, it's that. Now, again, it's going to be, because I have the hypotenuse, I have to go the hypotenuse squared minus the leg squared. So 53 squared minus 45 squared. And let's see if I take the square root of it, if it's a perfect square or not. It is. It's 28. So that means that this side is 28. Okay, and then I just start going opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. I don't know if any of these reduce. You can check, though, by going like 28 over 53. Remember, it hitting math fraction. That does not reduce. 45 over 53. Hitting math fraction. Okay, so none of these reduce. So that's fine. That's good. And then now I just take them all over here and I flip them. So cosecant would be 53 over 28. Secant would be 53 over 45. And cotangent would be 45 over 28. Okay? Okay, guys, for this last one, remember, we're always working with fractions, so that's 7 over 1. We know that cotangent is the one that goes with tangent, okay? So if tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. You can draw your triangle, put your angle wherever you want. Okay, so that side's opposite. That side's hypotenuse, so obviously that's adjacent. So if I have adjacent and opposite. Now this time these are both legs, okay? So what we can do is we can go 7 squared plus 1 squared, because they're both legs, which is 50, which is not going to have a perfect square. So we have to do the square root of 50. Now this is going to break down, though, because 2 times 25, and 25 is 5 times 5. Okay, so the square root of 50 is 5 on the outside, 2 stays on the inside. So when I write down my ratios, all right, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. None of those reduce, and so I'll just flip them all. 5 root 2 over 1. You don't have to put the over 1 if you don't want. 5 root 2 over 7, and 7 over 1. Okay, so hopefully that all makes sense. SOHCAHTOA, I think that'll be pretty easy for you guys. Okay, our next section, you guys, is specifically right triangle trigonometry. We're still using SOHCAHTOA, but we're finding sides and angles, okay? The biggest thing is making sure that you set up your ratio correctly. So, for example, all right, that's opposite, that's hypotenuse. So we're going to use our sine trig function. So we go like this. Sine of 57 degrees equals opposite over hypotenuse. Okay, now, if you are trying to solve and the variable is on the top, it's pretty easy because you just multiply the number on the bottom over. But if you're trying to solve and the variable is on the bottom, it's a little bit harder. Remember what we would do in class is we would just switch those. And like, here's why, because what I'm really doing is I'm multiplying by x right there and getting x sine 57 equals 17, and then I'm dividing by sine 57. Okay? But a really fast way to do that, 17 divided by sine 57, is literally just switch the place of those two. And so bring the x up here and bring the sine 57 down here. Okay, so when you're solving this, guys, the most important thing is to make sure your calculator is in degrees. I lost the word on my head for a minute there. In this calculator, you hit mode and degree right there. Okay, and then I can go 17 divided by sine 57. All right, and it says to round to 1 decimal place, or it doesn't say, but I'll probably tell you that. So actually, we'll go three decimals because it doesn't say. How does that sound? All right. Okay, so it's like 27.270. If you're on Desmos, the place where you go to change it to degrees and radians is up this little wrench in the corner. You change that over to degrees, and then you go 17 divided by, under functions, sine 57. Okay? All right, our next one, we have opposite hypotenuse. That one's adjacent. Okay, so the ones that it gave me were opposite and adjacent, which is tangent. Tangent theta equals opposite over adjacent. Now this time, guys, we're solving for an angle, and whenever you're solving for an angle, you're trying to get the tangent to the other side. Okay? So it's going to be, oh, not sine, shoot, what am I doing? Inverse tan of 25 over 24. And again, as long as you're in degree mode, you should be good. So we go on this calculator, inverse tan of 25 over 24, which is 46.169 degrees. Okay. On Desmos, if we do inverse tan, which is under your functions, it's just right down below over here, inverse tan of 25 over 24, and we get 46.169. All right? Okay, now, solving a triangle is where it gives you, a right triangle gives you two pieces of information, either a side and an angle, or two sides, okay, is what it can give you, and you have to solve the rest of it. Now, what I'm going to do is, let me label these sides real quick. Opposite, hypotenuse, adjacent. I can decide which side I want to solve for first. Let's say I want to solve for this side that's opposite. Let's call that x, okay? So then I have the adjacent side and the opposite side. So I will write tangent of 24 degrees equals opposite over adjacent. Now, because the number is on the bottom, I just multiply it over, and that's what I'm going to type in. So in my calculator, I go 30 tan 24, which is 13.356. All right, we'll just go ahead and do one number, 13.4. Okay. Then how do I get the hypotenuse? Well, in order to get this side, you can either do another trig function, or you can just do the Pythagorean theorem. 13.4 squared plus 30 squared equals hypotenuse squared. Okay, so if I go, I'm just gonna type squared because it'll take that number right there and square it, and then I won't have a round off error. Plus 30 squared equals, and since we're in, decimals anyways, I get 32.8 for my hypotenuse. And then to solve the rest, the remaining part of the triangle, the only thing that's missing is an angle. And just remember, to get that angle, it's a whole triangle adds up to 180. We have a 90 and a 24. Okay, so 180 minus 90 minus 24 is 66. All right, so that angle is 66. So let's see here. AB is the 13.4. AC is the 32.8. And angle A was 66 degrees. Okay? Okay, the picture on this word problem is pretty straightforward. We have a ladder leaning against a building, and it's a pretty easy one to draw. We know it just looks like that. It says the base of the ladder is 19 feet from the base of the building. That would be that part, 19 feet. And the ladder is 30 feet. I forgot to write that down. And it wants to know, what is the angle of elevation? Okay, well, my right angle is here. So that's opposite. That's hypotenuse, so that's going to be adjacent. So I have adjacent and hypotenuse, which is cosine. So cosine of this angle is adjacent over hypotenuse. Okay, and again, just solving for an angle means we have to bring the cosine to the other side. So my angle is the inverse cosine of 19 over 30. So I'm going to go over here, inverse cosine of 19 over 30. Okay, and the angle of elevation is 50.7. All right. We'll probably just go to one decimal, so I could come up here and adjust these. That one would be 20.2 or 20.3 if you rounded it. And then that one would be 46.1 or 46.2 degrees if you rounded that one. Okay, so we'll just do one decimal place on all that. Okay, great. Our last section, here we go. Now this is where things got a little bit confusing, but the main thing that we remembered was this. Well, actually, okay, two things. So when you're drawing your triangles, right, just make sure you remember that, like, if it's in the first quadrant, it goes positive, positive. Okay, if it's in the second quadrant, it goes negative, positive. If it's in the third quadrant and you're labeling it, you go negative, negative. And if it's in the fourth quadrant, it goes positive, negative. So make sure that you check that both when you're putting the, like, labeling your triangle and when you're writing the answers. The other thing you can check is, if we remember the quadrants 1, 2, 3, 4 go A, S, T, C, all students take calculus and remind ourselves that that means all are positive in quadrant 1. Only sine and cosecant are positive in quadrant 2. Only tan and cotan are positive in 3. And only cosine and secant are positive in quadrant 4. Okay, so when it says that point is on the terminal side of theta in standard form, what that means is, okay, you draw this and you plot that point. Now when I plot that point, it's going to go left 6, up 12. And then I make my bow tie angle. Okay, the angle that we're looking at is that angle right there. And if I do the Pythagorean theorem, so I go, remember that the negatives go away anyway, so 6 squared plus 12 squared is c squared. Okay, so if I go 6 squared plus 12 squared, if I try to square root it, I get a decimal, which means I need to reduce the radical. So it was 180. So I would go like this. Okay, that's 18 times 10. That's 9 times 2. That's 3 times 3. That's 2 times 5. So I get a pair of 3s, 1 dies, and a pair of 2s, 1 dies. So 3 times 2 is 6, and a 5 left over. Now remember that hypotenuses are always positive. Okay? And so, if I label this, it's opposite, hypotenuse, adjacent. So here we go. Opposite over hypotenuse. Now, we do, remember, want to simplify. We don't have to rationalize. So 12 over 6 is just 2. Makes it easier when we flip it. Okay, cosine equals, cosine is adjacent over hypotenuse. So I can reduce the 6's and get -1 over root 5. And then tangent is opposite over adjacent, which is -2. Okay, I flip each of them. So cosecant would be root 5 over 2. Secant would be root 5 over -1, which you can write -root 5, or you can just leave it. And then cotangent would be -1 over 2. Okay? All right, perfect. Now, these are the ones where we have to actually find what quadrant it's going to be in, but it gives us a little bit of information. Okay? So for here, it tells me sine is negative. All right, now, I would kind of do this. Let's figure out where sine is negative. Sine is positive in 1 and 4. So sine is negative. I'm sorry. Sine is positive in 1 and 2. So it's negative in 3 and 4. Okay. And then the other one is, where is cosine? And look, guys, there's nothing there. So that's a positive. Where is cosine positive? Okay, well, I know that cosine is positive in quadrant 1 and 4. So which quadrant am I going to draw my triangle in? I'm going to draw it in quadrant 4. Okay? And then I'm going to just erase this to make it look a little cleaner. All right? So this is going to be in quadrant 4. Cosine is positive and sine is negative. Now we know the cosine ratio is adjacent over hypotenuse. And we know that this one is opposite. This one is hypotenuse, so that one's adjacent. So adjacent over hypotenuse is 5 over 7. Okay, if I do the Pythagorean theorem, it's 5 squared plus x squared is 7 squared. So I subtract 7 squared minus 5 squared. And I get 24. And I know I can't square root 24. So we're going to do a reduced radical for this also. All right, let me do it up here. So the square root of 24, let's see, this is 212, 26, 23. Pair of 2's. And so the 2 comes out and the 6 stays in. That's the opposite side. Okay, now the only thing that this is missing, and it's really hard to not make this mistake, but remember, when we're in the 4th quadrant, we go positive, negative. So I have to remember to put a negative on there. It's very tricky. Easy to forget because we're doing so many things in this problem. You have to remember to put a negative. So now it goes opposite over hypotenuse. Cosine is over here. That's adjacent over hypotenuse. And then tangent, which is opposite over adjacent. Cosecant flips sine. Secant flips cosine, which was over there. And then cotangent flips tangent. Now, what I like to do to check myself at the end is, if I know I got my quadrant right and it's in quadrant 4, A, S, T, C, that's the C quadrant, I make sure that cosine and the one that goes with cosine are positive, and I make sure that everything else is negative. Okay? So that's just something I like to do at the end because I've forgotten my positives and negatives on there too many times. All right, great. Let's do one more. Okay, these are both reciprocal functions, so I got to be really careful with this. All right. Guys, cotangent goes with tangent, and bigger than 0 means positive. Cosecant goes with sine, and -3 means negative. Okay, now, tangent is positive in 1 and 3. Okay, sine is positive in 1 and 2, so it would be negative in 3 and 4. So sine is negative in quadrant 3. Sine negative, tangent positive. Okay, so we put it in quadrant 3. All right. Now, sine is opposite over hypotenuse, which means cosecant is hypotenuse over opposite. Here's the thing, though, guys. Remember, this is like over 1 because we have to have a fraction, and that negative might not go there. In fact, it doesn't because your hypotenuse is not allowed to be negative. So that negative does not actually go with the 3. It goes with the 1. That's what's a little tricky on this problem for sure. So 3 is the hypotenuse. That's there. Negative 1 is the opposite, and now I have to find the adjacent side. Okay? That's hypotenuse. That's opposite. I got to find adjacent. Now, my Pythagorean theorem, the hypotenuse is 3. That's what it has to equal. So it's negative 1 squared plus x squared is 3 squared. Okay, so when I'm solving it, I go 3 squared minus 1 squared. Remember, you really don't even, when you're doing the Pythagorean theorem, you don't have to do the negatives because the negatives are going to depend on where the triangle is in what quadrants and stuff anyways. So if I go 3 squared minus 1 squared, and I get 8, okay? And the square root of 8, I have to break down. 2, 4, 2, 2, pair of 2's, and I get 2 square root 2, and now I can do all my stuff. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then cosecant is up there, that flips sine. Okay, secant flips cosine, and cotangent flips tangent. You could also write that as negative 2 root 2. There we go. All right, that's essentially exactly what your test is going to look like, is those 5 sections. All right, great job, guys.